In this video, we want to learn about double integrals over rectangles, and also we want to learn how we can use double integrals for finding volumes. Here we have two examples of finding double integrals, but if you pay attention, the function in these two examples is the same. The function is 2x to the 2y. The difference is that in the first integral, we want to find the integral of this two variable function with respect to y first, then with respect to x. But here, the order is changed. First, we want to find the integral of this function with respect to x, then with respect to y. But attention that because we have reversed the order of integration, we have switched these two upper bound and lower bound of the integral. Here x is from 0 to 3, y is from 1 to 2. In this integral, y is again 1 to 2 and x is 0 to 3. So the interval is the same. And because we have reversed the order of integration, so automatically we have to reverse these values also. Let's see, is there any relation between these two values or not? Let us start by finding this integral. We want to find integral from 0 to 3, 1 to 2 of 2x to the 2y dy dx. For finding the integral, double integrals, we start from the inner integral. So we want to find first the integral of this function with respect to y from 1 to 2. And attention, when we are finding the integral with respect to y, the x is a constant. At that moment, x is a constant for us. So it's a coefficient for y. So simply, we can think this as y dy. This is the function that we want to integrate. And 2x to the 2 is a coefficient for that. Keep this in your head. Let us start finding this integral. So we have integral from 0 to 3. What is integral of 2x to the 2y dy? Please focus on this inner integral. Because 2x to the 2 is a constant, we leave 2x to the 2 here. And only we have to find integral of y to the power of 1 dy. With the power rule, integral of y is y to the 2 over 2. Now that we have find this inner integral, we remove the integral notation and the dy because these are the integral notation. We integrated the inner function, the function with respect to y, so we don't need to write dy and the integral notation anymore. But don't forget, we have to find the value of this from 1 to 2. And don't forget to write the x here. Before I substitute 2 and 1 for y, let's simplify this expression inside the bracket. 2x to the 2 times y to the 2 over 2. The 2 from numerator with 2 from denominator cancels, so we can simplify this expression inside the bracket, and we can simply write x to the 2, y to the 2. Now, in this expression in the bracket, we have to plug in 2 for y and 1 for y, and we have to subtract these 2 from each other. So we have integral 0 to 3. If we plug in 2 for y, then we have 4x to the 2, because 2 to the 2 is 4. We plug in 2 here, 2 to the 2 is 4, so 4x to the 2. Minus, we plug in 1 for y. 1 to the 2 is 1, 1 times x to the 2 is x to the 2. Minus x to the 2 dx. 4x to the 2 minus x to the 2 is 3x to the 2. So integral from 0 to 3 of 3x to the 2 dx. Now this is a simple integral with one variable, x. What is the integral of 3x to the 2? Based on the power rule, again, the integral of x to the 2 is x to the 3 all over 3 from 0 to 3. If we simplify this, basically this is x to the 3. 3 with 3 cancels, and only we have x to the 3 from 0 to 3. If we plug in 3, 3 to the 3 is 27. If we plug in 0, it's 0, so we don't need to plug in 0. So the value of this integral with this order of integration, first with respect to y, then with respect to x, is 27. Now let's see what is the value of the other integral. Here we want to find first the integral of the function first with respect to x, then with respect to y. So focus on the inner integral, this integral. For finding this integral, we write integral from 1 to 2. Here we want to find the integral of 2x to the 2y dx with respect to x, because here we have dx. And attention, when you are finding the integral with respect to x, these two here and this y are like coefficients, are like numbers for x to the 2. Focus on the x to the 2. What is integral of x to the 2 based on the power rule? It is x to the 3 over 3. And don't forget, you have a 2 and a y as coefficients for 2x to the 2. So, what is integral of 2x to the 2y dx? The integral is 2 times x to the 3 all over 3 times y, and all of this from 0 to 3. And don't forget, you have to write dy here. Of course, we can simplify this expression. 2 times x to the 3 over 3 times y. Attention, we have 2 times by x to the 3 over 3 times by y. Multiply numerator by numerator, denominator by denominator. Basically, this can be written in the form of 2/3 x to the 3 y. So this is the better form for this expression. So let me erase this from here and write simply 2/3 of x to the 3 y. Now we have to plug in 3 and 0 for x. Attention, we integrated with respect to x, and x is from 0 to 3. Now we plug in 3 for x and 0 for x. If we plug in 3 for x, this equals integral from 1 to 2. When we plug in 3, 3 to the 3 is 27. 27 divided by 3 is 9. 9 times 2 is 18. So we have 18y. If we plug in 0 for x, this would be 0. So only we have 18y dy. Now this is a single variable function, so it's a normal integral, and it's easy to find this integral with the power rule. The integral is 18 times by y to the power of 2 over 2. The integral of y to the 1 is y to the 2 over 2. If we from 1 to 2, if we simplify this, this equals 18 divided by 2 is 9, so it's 9y to the 2 from 1 to 2. If we plug in 2, 9 times 2 to the 2 is 36. If we plug in 1, 1 to the 2 is 1 times 9 is 9. 36 minus 9 is 27. Please notice that the answers that we got from integration of the function with respect to y, then with respect to x, is the same as the answers that we got from integration with respect to x, then with respect to y. Is this by a chance and only it's because this only in this example this happens? No. In general, it turns out that under good conditions, the two iterated integrals are always equal. So the order of integration really doesn't matter. You can take integral of a function with two variables, with respect to x, then with respect to y, or you can find the integral with respect to y, then with respect to x. But what is the condition that the answers are the same? Not always the answers are the same. Under some conditions. What is the condition? The condition is that the function here, the function should be continuous over the rectangle. So in general, if f is continuous function over the region, then the order of integration doesn't matter for f. If f is a function that is continuous, if we find the integral with respect to x then with respect to y, it's the same as finding the integral of the function with respect to y then with respect to x. And of course here we have to write c to d, a to b, because we have reversed the order of integration. We have to change the order of writing the lower bound and upper bound of the integral. So for almost all the functions this is true, but there are examples that if the function is not continuous, then the values are not the same. And I have a video for this that I have shown, and in that video that order of integration, when you change the order of integration, the value of the integral would change if the function is not continuous. So it's important that the function should be continuous over the region. Here we have another example of finding a double integral over a rectangular region. The rectangle is x between 0 and 2 and y is between 1 and 2. Let me draw the rectangle here. It's not important, but it's good to see the rectangle that we want to find. The integral of this function over there, that region. X is between 0 and 2. So let's suppose here is 2, 0 to 2. And y is between 1 and 2. So if we suppose 1 is here, 2 is here, y is between 1 and 2. X is between 0 and 2. So the region is this rectangle here. Here is 1, here is 2, y is between 1 and 2 if you pay attention in this rectangle, and x is changing from 0 to 2. And this is a surface that we want to find integral of the surface over that region. So let us start finding the integral. First, let's find the integral with respect to x, then with respect to y. Because we want to find the double integral first with respect to x, then with respect to y. So x is changing from 0 to 2, attention, y is changing from 1 to 2. For finding integral with respect to x, again please focus on the inside integral. And attention, when we are finding integral with respect to x, the y is a constant. First we have to find integral of x with respect to x. Based on the power rule, integral of x is x to the 2 over 2. We have to write integral 1 to 2. Integral of x is x to the 2 over 2. But attention, when we are finding integral of 3y to the 2 with respect to x, this is like a number, this is like a constant. For example, this is like 5 dx. What is the integral of 5 dx? 5x. So this is a constant. We put the constant, integral of dx is x. So what is the integral of 3y to the 2? Is 3y to the 2x minus 3y to the 2x. And this is from 0 to 2 dy. Now we substitute 0 and 2 for x. First we substitute 2 for x. So we have integral 1 to 2. If we plug in 2 for x, 2 to the 2 is 4. 4 divided by 2 is 2. Minus, if we plug in 2 in the other term, if we plug in 2 here, 2 times 3 is 6 minus 6y to the 2 dy. Now we have to find this integral. Integral of 2 is 2y. Attention, it's with respect to y. So 2y minus. What is the integral of 6y to the 2 dy? Based on the power, it's 6 times y to the 3 over 3. If we simplify 3 with 3, we have 2y to the 3 minus 2y to the 3. All of this is from 1 to 2. If we plug in 2 in this expression, we have 2 times 2 minus 2 times 2 to the power of 3. If you calculate this, this is 4 minus 16, and all of this is negative 12. If we plug in 1 here, 2 times 1 is 2. 2 times 1 to the 3 is also 2. 2 minus 2 is 0. So when we plug in 1, this is 0. So the value of this expression When we plug in 2 is negative 12. When we plug in 1 is 0. So the value is equal to negative 12. So the integral of this function in this region is negative 12. Now let's see what is the value of the integral if we change the order of integration. The integral from now is from 0 to 2, 1 to 2 of x minus 3y2 dy dx. Now we have to find integral with respect to y. And because we are finding integral with respect to y, the x is a constant. So what is the integral of x dy? xy, not x to the 2 over 2. Because the integral is with respect to y. So x is like a number. We write the number x and integral of dy is y. What about 3y to the 2? Integral of 3y to the 2 is y to the 3. Y is from 1 to 2 dx. The integral of 3y to the 2 is 3 times y to the 3 over 3. 3 with 3 cancels and it's y to the 3. Now let's plug in 1 and 2 for y. If we plug in 2, we have, so this equals integral 0 to 2. If we plug in 2 for y, we have 2x minus 2 to the 3 is 8 minus. If we plug in 1 for x, we have 1x which is x. 1 to the 3 is 1. And we have to find integral of all of this with respect to x. If we simplify this, this equals integral 0 to 2. 2x minus x is x. Minus 8 plus 1 is minus 7 dx. Integral of x is x to the 2 over 2. Integral of 7 is 7x. And all of this is from 0 to 2. If we plug in 2 in this expression, 2 to the 2 is 4. 4 divided by 2 is 2. If we plug in 2 in the other term, 7 times 2 is 14. 2 minus 14 is negative 12. So this is also equal to negative 12. If we plug in 0, all of these terms are 0. So, as you can see, again, the answers of the integral is the same when we change the order of integration. When we reverse the order of integration, the answers are the same. But don't forget, we have a condition for that, which almost always we have that condition for our integrals. Now you have to learn something from these two examples. When you want to find integral of a function over a region, it's important that you choose an order that helps you to find the integral easier. Sometimes if you change the order of integration, maybe finding the integral is harder, or even we have examples that it's impossible. So changing the right order can help you to find the integral easier, because the answer is the same at the end. So we use the order that makes the integration easier. Keep this in your head. This is an important thing to remember. Before I show you the next example, let me show you something about this function, this surface, and this region, so we can understand what we did here and what this number negative 12 basically represents and it means. We know that double integral of a function over a region shows the volume under the surface. But why here the answers are negative if it shows the volume? It's because this surface in this region is not above xy plane. This is x and y axis. The graph of this function, this two variable function, is below xy plane, and for that reason it makes sense that the answer of the integral is negative 12. If we want to give an interpretation for this negative 12, it is negative of the volume between this function and the xy plane in this region. This is the interpretation that we can have. So it is negative of the volume, not the actual volume, because the volume is basically 12. Let me show you the graph of the function and this region so we can see what we calculated in this example. Here you can see the surface x minus 3y to 2, or z equals x minus 3y to 2, which is this blue surface that you can see here. As you can see, it is completely below the xy plane in that region. And attention, if you attention here, x is between 0 to 2 in the x coordinate, and the y is between 1 to 2, if you can see. And as you can see, the graph is completely below the xy plane, and that's the reason that we got negative number for the volume. Instead of actual volume, we got the negative of the volume. I hope now you understood why we got the negative number for the answer. Let's back to our next example. Now look at this example. We want to find the integral of the function x sine of xy with respect to y, then with respect to x. Y is from 1 to 2, x is from 0 to pi. Before we start the calculation, let me mention something. Suppose this integral was given in the form of integral from 1 to 2, 0 to pi, x sine of xy dx dy. Suppose this was the given question and we want to find this integral. If we want to find the integral of this function with respect to x, because x appears here and x appears in the sign, for finding the integral with respect to x first, we have to use integration by parts method, and it makes the calculation more difficult than finding the integral in this order. So if we had this question, it was a good idea to rewrite it in this form and find the integral in this order. So sometimes it's a good idea to change the order of integration when we have a rectangular region. But here we are lucky that the given order is the order that makes the calculation easier. First, we have to find the inner integral. We have to find the integral of x sine of xy with respect to y. And y appears in the sign here. And this is like a coefficient, and you can move it to the outside if you want, because it's a constant. So for finding this integral, we can simply write integral from 0 to pi. X is a coefficient. What is integral of sine? If you remember, integral of sine of u du is negative cosine u. So integral of sine of y dy is negative cosine of y. But here we have x here. What do we have to do with that x? Suppose you have a 2 here. What is integral of sine of 2y? Integral of sine of 2y is cosine of 2y, because it's a coefficient, it's a constant. If you want, you can use u substitution here, and you can suppose this as u, find du, but this is not really complicated integral, and you don't really need to do substitution, to use u substitution. When you have a coefficient times by y, integral of sine of 2y, for example, is cosine of 2y, but don't forget you have to put 1/2, or basically derivative of 2y, the reciprocal of derivative of 2y here, 1/2 here. Why we have to put 1/2 here? Because if we take derivative of cosine is sine. Negative sign by negative cancels and it's sine. Derivative of the inside would give you an extra 2, but these 2 cancels that 2, and we have exactly this answer. So finally, what is sine of xy dy? The integral of sine of xy dy is cosine of xy. Attention, derivative of cosine is sine. And we have a negative in the answer because integral of sine is negative cosine. So let me put the negative here. What else we have to multiply this by? Reciprocal of this number. Because when we are finding derivative of cosine, Derivative of cosine is negative sign, which is here. But derivative of the inside, derivative of xy with respect to y would give you an extra x. For that reason, we have to put the reciprocal here. So finally, integral of sine of xy dy is 1 over x cosine xy. And all of this is from 1 to 2 dx. First of all, note that x with x cancels. So basically we have integral 0 to pi of negative cosine xy from 1 to 2 dx. If we plug in 2 for x, we have negative cosine 2x. And if we plug in 1, we have plus cosine x dx. Remember, we have to subtract this from this, so we have a plus here. Now we have to find the integral with respect to x. Integral of cosine of 2x, we have to put the negative here. Integral of cosine of 2x is sine of 2x. Don't forget reciprocal of the coefficient here. And integral of cosine x is sine x. And all of this is from 0 to pi. If we plug in pi here, sine of 2 pi is a full circle, we back to the 0. Sine of 2 pi is 0. So when we plug in pi here, this is 0. And if we plug in pi here, sine of pi is here. And we know that at 180 degree, sine is 0. So when we plug in pi, both of the terms are 0. And when we plug in 0, sine of 0 is 0, sine of 0 is 0. So it seems that the value of the integral equals 0. And at first it seems really odd why the value of the integral is 0. This is because if we look at the graph of this two variable function in this region, we will see that in part of this rectangular region, the graph of this function is below x-axis, below xy plane, not x-axis, below xy plane, and in part of this region, the graph of the function is above the xy plane. For that reason, these two volumes cancel each other, because in the integral, when we are finding integral, when the function is below xy plane, the value of the integral is negative. When the function is above xy plane, the value of the integral is positive. These two cancel each other. So at the end, we get 0. So you should not make this mistake to think that the volume is 0. No. Part of the volume is above xy plane, part of the volume is below xy plane, and because of this calculation, the positive and negative cancel each other. Let me show you the graph of this function so you understand better how this has happened. As you can see here, the graph of the function x sine of xy, as you can see, part of the graph is above the xy plane, and part of the graph is below the xy plane. And these two volumes are exactly equal, and so they cancel each other, and the value of the integral is 0. Now look at this example. Integral from 1 to 4, 1 to 2 of x over y plus y over x dy dx. First we have to find integral with respect to y, then with respect to x. Before starting finding the integral, we can think to changing the order of integration. But if we look at the equation of the function, you can see that the changing the order really doesn't change anything, because it's almost symmetric, the given equation. So really the order of the integration doesn't matter here. So we keep the order as it is, and we start finding the integral of the function. First with respect to y. This equals integral 1 to 4 of integral of x over y is with respect to y. Attention, because it's with respect to y, so x is in the numerator is a constant, we leave the x, and integral of dy over y is ln of y, or ln of absolute of y if you want to write it this way. What about integral of y over x with respect to y? Now here this is a number, so we have y to the power of 1 dy, and based on the power rule this integral equals 1 over x. Attention, we have x in the denominator and we write it as in the form of 1 over x times by y to the power of 2 over 2. With the power rule, integral of y is y to the 2 over 2, and all of this is from 1 to 2 dx. Now we have to plug in 2 for y, 1 for y, and we have to subtract these two from each other. Then we have integral from 1 to 4. If we plug in 2, we have x ln of 2 plus, if we plug in 2 in the other term, in the next term, we have 1 over x times by 2 to the 2 is 4. 4 over 2 is 2. So we have 2 over x minus, now we have to plug in 1 for y. If we plug in 1 here, this is 0 because ln of 1 is 0. And if we plug in 1 here, we have 1 over 2 times 1 over x. So we have 1 over 2x minus 1 over 2x dx. All of this in a bracket. If you pay attention, 2 over x minus 1 over 2x, these are similar terms. So we can subtract these two from each other and we can write these two as a single term. Let me show you. 2 over x minus 1 over 2x with a simple common denominator. The common denominator is 2x. For the first fraction we have 4 minus 1, so this equals 3 over 2x. This is a simple subtraction of two fractions. So we can simply write this in the form of 3 over 2x. So we have 3 over 2x dx. Now we have to find integral of these two terms. Integral of x ln of 2. ln of 2 is a constant, so leave the constant. Integral of x is x to the 2 over 2. So x to the 2 over 2 ln of 2. What about the next one? 3 over 2 is a constant, is a coefficient. Put it outside, put it as a coefficient, leave it. Integral of dx over x is ln of x. So the integral of this term is 3 over 2 ln of x, or ln of absolute of x, from 1 to 4. If we plug in 4, and if we plug in 1, and if we subtract these two from each other, we can find the value of the integral. By plugging, if we plug in 4 to the 2 is 16, 16 divided by 2 is 8, 8 ln of 2. And if we plug in 4 here, we have 3 over 2 ln of 4. All of this minus, now we have to plug in 1 in these two terms. If we plug in 1 in the first one, we have 1 over 2. 1 to the 2 is 1, so 1 over 2 ln of 2 plus 3 over 2 ln of 1. But ln of 1 is 0, so this term is 0. So finally we have 8 ln of 2 plus 3 over 2 ln of 4 is 3 ln of 2. Why? Because 4 is 2 to the 2. The 2 goes to here. We have this property for ln. The 2 with 2 cancels, so this can be written as 3 ln of 2. And attention, this simplification that I am doing in the answer is optional. You don't really need to do this simplification, and you can write the answer in this form and you can leave it. But it's better to simplify the answer if it is possible. Minus 1/2 ln of 2. Now if we do a simple common denominator between 8, 3 minus 1/2, because these are the same, 8 plus 3 minus 1/2 would be 21 over 2. With a simple common denominator we can see that. And this is the answer of the integral. And this is a positive number, which shows that this function in this rectangular region is above xy plane, and for that reason the answer is positive. In this example, we want to use double integral for finding volume under a function. Find the volume lying under elliptic paraboloid x to the 2 over 4 plus y to the 2 over 9 plus z equals 1, and above the rectangular region, the region is from -1 to 1, x is from -1 to 1, y is from -2 to 2. First, we have to write this elliptic paraboloid, this function, this given function, in the form of z equals f of x and y. Because we have to write the function in this form, then by finding the double integral of the function z, which goes to here, we can find the volume. So, first let's solve this given equation for z. By solving this for z, z equals 1 minus x2 over 4 minus y2 over 9. So this is the function that we have to find its integral over this region. So the volume equals double integral of 1 minus x2 over 4 minus y2 over 9. Now we have to decide that we want to find the integral first with respect to x, then with respect to y, or dy dx. Which order we want to choose. Because this is a rectangular region, and this function really doesn't matter if we take the integration with respect to x, then y, or y, then x. It's up to you. You can choose both of the orders because the calculations would be very similar. And the calculation is easy, but it takes time, of course. So I'm going to choose dx dy. X is between, attention, this is for x, the first one is for x from -1 to 1, and y is from -2 to 2. We have to find the integral of the bracket first with respect to x. So this equals integral from -2 to 2. Integral of 1 is x. Integral of x to the 2 is x to the 3 over 3, but we have a 4, so x to the 3 over 12 minus. Now that we want to find the integral of this is like a 1. Integral of 1 is 1x. Integral of y to the 2 over 9, dx is y to the 2 over 9x. And x is from -1 to 1 dy. Now the only thing that here we have to do is to plug in 1 and then -1, subtract them from each other. If we do this, we have this equals integral from -2 to 2. If we plug in 1 for x, we have 1 minus 1 to the 3 is 1 over 12 minus, if we plug in 1 here, 1 times y to the 2 over 9 is y to the 2 all over 9. Then we have to plug in -1 for x. Then we have -1 minus -1 to the 3 is basically plus 1 over 12, because -1 to the 3 is -1 times negative would be plus. And finally we have plus y to the 2 over 9 and all of this dy. So simply here we substitute 1 and -1 and we subtract these two. Now if we simplify this equals integral from -2 to 2. 1 minus -1 is 2. -1 over 12 minus 1 over 12 is minus another 1 over 12. So in total we have minus 2 over 12, which can be written as 1 over 6. Minus y to the 2 over 9 minus y to the 2 over 9 is minus 2y to the 2 over 9 dy. Now if we simplify, 2 minus 1 over 6, 2 minus 1 over 6 is 11 over 6. So this equals integral -2 to 2, 11 over 6 minus 2 over 9y to dy. For finding this integral of 11 over 6 is 11 over 6y minus integral of 2 over 9y to the 2 is 2 over 27y to the 3, because integral of y to the 2 is y to the 3 over 3. And all of this is from -2 to 2. If we plug in 2 and then -2 and we subtract these two values from each other, simply By a simple calculation, we can see that the value of this integral equals 166 over 27. Before I finish this video, let me tell you about something about this calculation that here we did. If you pay attention, here we want to find the integral of this expression, this function, with respect to x from -1 to 1. Because the integration is from -1 to +1, and this function, if you pay attention, is even, simply you can change the integral from -1 to 1 to 0 to 1, and you can double this, because for even functions we know that instead of finding integral from -a to a of the function when f is even function, we can simply write the integral in the form of 2 integral from 0 to a of f. But this is not something that is really important, but it's good to know because it makes the calculation a little faster if you know these things. And also here for y we had same thing. When you get to this function is again even function with respect to y. And so instead of finding this integral from -2 to 2, you can simply write 0 to 2, but you have to double your answer. So this is a rule for integrals with one variable, and it works for functions with multi-variables also. So finally, this answer shows the volume that lies under this elliptic paraboloid in this region. Let me show you the graph of this elliptic paraboloid, and then we finish this video. Here you can see the graph of that elliptic paraboloid, and these lines that you can see here are the rectangular region, because this elliptic paraboloid extends over the xy plane and it goes down forever. But here you can just see the part of the elliptic paraboloid that is above the xy plane and is in the rectangular region. Here you can see the graph of the elliptic paraboloid. And so that value that we got, which was I think 166 over 27, is the volume under the surface, under this surface above the xy plane in this rectangular region that you can see here. I hope by watching this video you have learned about double integrals and how we can use them for finding volumes. If you like this video, please subscribe to my channel and see you in the next videos.